Here's a typical problem for these types of ODEs. So you're saving for retirement, you have a continuous compound interest rate of 5%, and you're going to save for 40 years. You want to have a million available at retirement. So how much to deposit each year into the savings account? And a couple things here. A more realistic compound monthly needs more investment, right? You get a little bit more money if you compound, you have a continuous compound interest. And then also keep in mind you are fighting against inflation. So as the money is accruing in value, it's essentially, devaluing because of inflation. But on the flip side, if you have a loan, inflation is actually good for you because kind of the value of the loan should go down relative to your wages going up with inflation. Here we go. So we've got our differential equation here. We have s prime is equal to r times s minus k. I want to figure out what k is. And we also have that s at time 0, we're going to say is 0. We don't have anything in the savings account when you start saving. We also have s and time 40 years. We want it to be 1 million. Alright, so then what does k have to be? So we can fill in this r here. So we got s prime equals 0.05 s minus k. If you solve this, the solution to this differential equation, right, this is a separable differential equation, it ends up being s naught times e to the, in general it's rt, plus k over r times e to the rt minus 1. So that kind of makes sense. If you plug in t equals 0, you get this k over r times 1 minus 1 when t equals 0, so that goes away. And then e to the 0 here, so you get s naught. And then you're accruing interest on your initial, but you're also accruing some interest based on the amount you're putting in each year. Alright, so for us, we have s naught is equal to 0. So we're going to have our s of t is equal to 0 there. So we just have k over 0.05 times e to the 0.05 t minus 1. And now if we want to solve for k, we can use this other condition we have. We want s at 40 years is equal to a million. Let me just do 10 to the 6th. A little easier to write. It's 10 to the 6th. And so that's going to have to equal, well, we plug in 40 into this equation, so we get k over 0.05, and then here we get e to the 0.05 times 40 minus 1. Alright, and so in here you can solve for k, you have to divide and stuff like that. So k ends up being, let's see here, 0.05 times 10 to the 6th all over e to the 0.05 times 40 minus 1. So it's approximately 7,825.88. It's not a whole lot to invest each year, but again, you are fighting against inflation. But also, again, on the plus side, if you do have a loan, like a student loan, and inflation is actually good for you because it will actually decrease the value of the loan, because the value of each denomination of money is actually decreasing over time due to inflation. But yeah, it definitely pays to start saving early because you get a lot of interest accruing over 40 years for the stuff that you start investing early on, and then you get interest on that interest, and yeah, good idea.